Another example here of finding the derivative of trigonometric functions. Here y equals secant root x plus the root of secant x. So in this example, we're demonstrating the difference of the root of the argument or the root of the entire function, the trigonometric function. So to take the derivative, we should actually begin by rewriting using half to represent the roots. So this is x to the half, so only x has the exponent, plus here we have secant x all to the power of a half. So the entire function, or the entire trigonometric part, has the exponent. So differentiating then, in this part, the trig function comes first. So the derivative of secant, if we take a quick glance at our table here, is secant x to the half tan x to the half. So that's the derivative of the secant. Now we take times the derivative of the argument. So the derivative of x to the half is a half x to the minus half. So that's the derivative of this part. That's plus the derivative of this part. Now the difference here the x had a half, here everything is to the power of a half. So we'll bring the half down front because now the exponent is the outside function. The inside will stay the same, and that'll be to the power of minus 1 over 2. Multiply that by the derivative of what was inside. So the derivative of secant, again, is secant x tan x in this case. And that all has to be multiplied now by the derivative of the argument. So the derivative of x here, which is 1. So not a lot of simplifying to do, but sometimes it looks nicer to get rid of the negative exponents. So we can write secant x to the half, or secant root x at this point, whichever you feel more comfortable with, over 2x to the half. So that's this section, plus we have secant x tan x over 2 secant x all to the power of a half. And we've simply gotten rid of the negative exponents. We could actually simplify a little here, but for our purposes this is fine